Hello, room 31. Today you get me. Disappointing. Well, maybe next week there'll be another guest. So let's remind you about the essential question, which is what can you discover when you look at something closely? So today we're going to be starting to read about molecules and how they change. And some of you might need a reminder, a molecule. Let's see. So if I had a piece of paper and I made it smaller, it's still paper. It's still paper, right? So I can get it super duper small where you can't see it anymore because now it's just a molecule of paper. So a molecule of paper will act and behave just like paper. And if it got any smaller, then it would stop being a molecule. So some of you may have studied with me that things that are smaller than a molecule are atoms, electrons, protons, and neutrons. So we can't have an electron of paper. We can only have a molecule. So a molecule is the smallest substance. But this paper is made up of billions and billions, I should have said trillions, of molecules. There are so many molecules in there. Okay, so we are reading specifically about A Drop of Water by Walter, who is he? By Walter Wick. Here we go. Let me move again. I always like to look at the pictures. So this looks like a dropper, like an eyedropper. And it's picked up water and then they're dropping it down. It looks like into a jar. Yeah, I can tell it's a jar because this same top is over here as well. So this looks like colored water, dye being dropped into regular water, and you could see it starts to combine together, and we'll talk about that. So we always want to look at the headings, molecules in motion. That tells me that all of these paragraphs will be about that topic. The molecules are in motion. I'll zoom in a little bit for you. If a drop of water is added to a jar of still water, and if the water in the jar is not stirred, where will the new drop go? Will it stay near the top or sink to the bottom? Here's a simple experiment that reveals the answer. A drop of blue water enters a jar of clear water. That's what's happening on the right. It begins to split up. Parts of the drop sink and swirl in different directions. At last, the colored drop breaks into so many parts that it has become part of the whole jar of water. So the new water that you introduced becomes just part of the whole entire jar. The molecules in a liquid are moving all the time. That's weird because what's that saying is a glass of water, if it's just sitting there on your counter, it's actually moving because the molecules are moving. They don't just sit still. All the time. They're pushing and pulling each other. I'm right here. Oops. Gotta click a little bit differently right there. Attaching to and breaking away from neighboring molecules. Neighboring molecules just means here's a molecule and here's a neighboring molecule. They're next to each other. The molecules in the blue drop break apart because they are pushed and pulled all over the jar by other water molecules. The energy that keeps the molecules moving is heat. This heat can come from the sun or the room in which the jar is standing. Without heat, water would not remain a liquid. It would become a different, a different state of matter, right? So solid, liquid, gas, those are the different states of matter. And water has that. Water has water vapor when it's floating in the air. It has a liquid when it's in a jar. And it has a solid when it's solid water, ice, right? And all of these different states of matter deal with different temperatures. Let's see if we talk about that. Next page. Up here on the upper left, we're always looking at what? We're always looking at the headings. So we know we're going to read all about ice in this section. Let's just see what else we're going to read about. On this page, we're going to read all about water vapor. So that is one of the states that I mentioned. What state is ice? Ice is the solid. When water cools, it loses energy. The molecules slow down and eventually stop swirling and pushing each other. When water freezes, the molecules lock together, forming a rigid structure. Structure is how you build something. A drop of blue water no longer moves. The water has changed from a liquid to a solid, ice. Ice is a solid, like metal or rock. But unlike metal or rock, ice is solid only at temperatures of 32 degrees Fahrenheit, which when we see something in parentheses right here, let's see if I could click properly. The click's a little bit messed up. You're looking right there. See in parentheses, it says 0 degrees Celsius. That tells us that 32 degrees Fahrenheit is the exact same thing as 0 degrees Celsius. At room temperature, ice melts. Remember, room temperature is about 72 degrees Fahrenheit. At room temperature, ice melts, changing back to a liquid. So here they have a picture of a block of ice, piece of ice, but it's just sitting out in the room and it's going to melt because it has to stay 32 degrees in order to stay a solid piece of ice. Moving up to water vapor. Water always seems to be disappearing. From wet clothes on a line, right? The water disappears from the wet clothes. From the puddles on the ground, if you see a puddle on the ground at school, and then you come back later, the puddle has gone. And from dishes on a draining board. We say it has dried up, but where has the water gone? When I was little, I used to think that water disappeared and it was no longer there. It actually does go somewhere. Just as water can be a liquid or solid, it can also be a gas. The water from the wet dishes evaporates. I'd like you to say that one out loud. It's right over here, the E word. It's hard. So the water from the wet dishes evaporates. Please say it. Evaporates. That is, it turns into a gas called water vapor. Molecule by molecule, the water from the drops on the wet dishes drift invisibly into the air. So if this is the dish and there's water right here, the water molecules are so tiny that they could float up into the air and they don't disappear, but they will just go somewhere else. So right now, is there water in the air? There actually is. It's just not a lot. Okay, and outside there is water in the air as well. Let's keep reading. The water from the wet dishes evaporates. That is, it turns into a gas called water vapor. Molecule by I'm reading the same thing. Molecule by molecule, the water from the drops on the wet dishes drifts invisibly into the air. Last paragraph here. Heating water in a kettle. A kettle is just like a metal, kind of like a can with a handle, and you could pour tea or hot water or something. It's called a tea kettle sometimes. Where am I? Heating water in a kettle speeds evaporation, so it speeds it up. Heat from the stove makes the water turn to steam, which is extremely hot water vapor. When the steam hits the cooler air, tiny droplets form, and we see a cloud just beyond the kettle's spout. Almost immediately, the droplets evaporate and change back to invisible vapor. Then the water molecules mingle. Remember, mingle is come together with other molecules that make up air. So I'm going to zoom in. So this metal part is the kettle. And that's not smoke, is it, right? Smoke is when something's burning, but we call this steam when it's from water. So there's water inside. We heat it up. It gets so hot that it comes on out. And when it mixes with the cool air, it forms these little tiny droplets that does look like smoke, but then it will evaporate and disappear back into the into the air as well. Okay, next page. We're going to read about evaporation versus condensation. And over here, we're just going to read about condensation. So we've heard a little bit about evaporation already, which is the water going into little tiny vapor molecules of vapor, and going into the air. Now condensation is going to be a little bit different, and then the next page will explain the difference. Okay, so let's keep an open mind here. We're trying to learn about this one, but we know we're going to compare it to something we've already talked about. Condensation. The air around us always contains some water vapor. Just like I said, there is water right in front of me. Water molecules move rapidly through the air and hit everything in their path. So water is hitting me in the face right now. The molecules bounce off most warm surfaces, but stick to surfaces that are cold. In these photographs, we'll take a look in a second. In these photographs, molecules of water vapor stick to the coldest part of the glass. Let's take a look. Oh, see, there's ice inside that's getting the glass to be cold. And then I guess when I was little too, I used to think that somehow whatever liquid was in the cup went outside the cup, but that's not true. If you had orange juice inside, you would not get orange juice outside because glass is solid and liquid cannot go through the glass. But let's read how it happens. Molecules of water vapor stick to the coldest part of the glass. Gradually, droplets form on the glass as the molecules accumulate. Accumulate is mingle. Accumulate is come together. Water vapor changes from a gas to a liquid. That is, it condenses. So do this with me. Condense. And if you want the opposite, expand. Condense. So let's take a look. If you see, take a look closely. What's happening is outside, the air outside of the glass, right? The air outside of the glass, it has water in it, but we can't really see it. But what happens is the air outside of the glass comes by and it sticks. Remember we said it sticks to cold things. So it sticks to the glass, right? And it stays there. You still can't see it. And then it happens again, and they mingle together. They accumulate together. And then once we get enough of them, then we'll have a droplet of water. So that's called condensation. Okay, this will be our last page. Evaporation versus condensation. In the photographs above, why do the water drops outside this glass disappear, while the drops inside remain? Outside the glass, the water evaporates and spreads throughout the room as vapor. In time, the drops disappear. Inside the glass, water also evaporates, but the vapor is trapped. The air inside the glass becomes humid. Humid deals with there being moisture. The air inside the glass becomes humid, which means that the air is full of water vapor, and that vapor condenses back onto the water drops as quickly as water molecules can evaporate. That's a lot of explanation, isn't it? So let's see. Outside the glass, the water evaporates. So on the outside of the glass, the water evaporates, and it just goes back into the room. And then the water droplets on the outside, they'll disappear. Okay. But inside the glass, the water is also evaporating, but the vapor gets trapped. That's important. It gets trapped and it can't release. That's because the air that is inside the glass, it's already pretty humid, and it has, so here's inside the glass. The air inside the glass already has a lot of water trapped in the air. Okay. So that all of that condenses, and those drops, they just stay into the water and they cannot evaporate. So that's why it says at the end, therefore the drops remain. Remove the glass and the vapor expands throughout the room. So if you just took away the glass, then the vapor would expand. Remember I said it's the opposite. Evaporation continues, but condensation slows down. In time, the uncovered drops will disappear. So, one last thing to say that's really neat about water is since the earth is created, all the water that's been on earth has stayed here. It doesn't go anywhere. You can't destroy water. You can just change it from solid liquid to a gas, and it will always stay here. So, I have some questions for you coming up, and I will see you soon.